Yo, yo, yo. What's up, everybody? Welcome back. Today we are working on our image editor, and the plan for today is to try to make some sort of like DAG visualizer for showing how a sequence of actions results in a final image. So this is my image editor. Maybe we can quickly show a simple case of trying to make a how we would construct something out of this. So we've been working on our like little test case here. We call it Slurpee Banister. We have Cersei Lannister from Game of Thrones. We wanted to sit on a banister holding a Slurpee because the name sounds similar, and we love rhymes around here. The way that we like compose things in this is we have like types of objects, right? So these are like image objects that we have here, and we can create like a composition object. And in this composition object, you can take like things, you can stick them together, right? Wow, crazy! So we got the Slurpee over here, we got the banister, we got Cersei. But say we want to like cut Cersei out so that we can sit her on the banister. That requires like another object. So we have like these path objects that allow us to create masks when we cut something out, right? So we take this path, this turns into a mask, and that mask goes through a like multiply shader. So one of the units of this image editor is like just arbitrary OpenGL shaders, and one of them is this guy. So we take the mask, this guy, and we apply him to the Cersei Lannister picture. But we could, in theory, apply that mask to any of the pictures, and that would work just fine. But in this case, it makes sense because we tried to use it on Cersei Lannister to apply it to Cersei Lannister as well. Now we also want to cut out the Slurpee, right? So we'll do the same thing here. We'll kind of make a new path. We'll cut out the Slurpee. We're not going to be too careful about it. And now in our composition, we should be using the cutout versions of both of these guys, right? So we'll kind of position her so that she's kind of maybe like this and like this. We would do a better job if we cared, but we don't. This is kind of just more to show off kind of how this editor works. Now, we look at this and we go, this looks like shit. It looks so bad. I want to go back and I want to like fix this mask to make it look better, right? So we can do that, right? So we go here, we go and we adjust the points on this mask, and oopsies. As we do that, those changes actually are getting applied downstream. So you can see it getting applied here, you can see it getting applied here, and you can see them getting applied here, right? But it's the changes that we've made are showing up. And what I've found trying to use this thing for real to do actual work is that trying to track this dependency tree is like a little annoying, right? If we were to try to like actually draw out what this thing looks like, we have our final composition, and he has 3 elements inside him, right? He's got the Cersei Lannister cutout, he's got the Slurpee cutout, and he's got the banister picture. Whoop. Right, the staircase. Well, we'll remember what these things are, okay? We don't have to criticize me too much on this. Now, these guys are all actually coming from somewhere else too, right? So the Cersei Lannister picture, this is coming from the mask. This is coming from this is coming from a shader. So this is a shader right here. Shader. And that shader has 2 image inputs. It has the original Cersei Lannister picture, and it also has the mask that we generated. And that mask that we generated comes from a path, like that path that we drew on top. And this path is then, this mask, as these 2 things are combined, and this path actually is also technically drawn on top of the Cersei Lannister, right? So we kind of like this tree of stuff. And this tree of stuff is like duplicated for the Slurpee, right? And so if I want to like work on this composition, I want to fix this mask. It's like we have this like flat image list, and I have to be able to look and figure out exactly which thing is in here. I'm thinking that if we had a tree of stuff, then we could just we would know very quickly. We could just like follow the tree. We go, okay, I'm looking at the composition. I want the Cersei Lannister. I guess I want to change the mask, and to change the mask, I have to change the mask. You just like follow the line backwards. The other thing that's kind of annoying right now is that I want to change how this Slurpee looks in the context of this picture, right? But in the context of this picture, I don't have like the handles to do so. I have to go back to this picture, fix it, and then go back over here and look and say, did it change the way I want it to? So I want to kind of fix both of these problems at once by basically drawing this tree in the image editor and making it so that when I click any of the items in this tree, like the image editor will be showing this guy, right? He will always show this. We'll draw a little eyeball here. But depending on which thing I click on, I'll have like all of the properties to change that thing, right? So if I want to go to say I wanted to add like a circle to this thing, right? We have the ability to do so. We create a circle thing and we make them a little smaller and we add this circle to the composition. Maybe we put it over her face or something, right? We're like, we want Cersei Lannister, no face. And if we wanted to go in here and we wanted to change the color to kind of match the surroundings, all that is like we change some sort of like color on this guy, right? And it would be nice if I could basically like click on this and have like the color stuff show up on the left, right? That's kind of what I want, is like when I click on, wait, this would now be like a circle here. I would like to click on this in the tree and have it highlighted and then show the parameters here. That's kind of what I'm thinking. Now, there is like, I'm taking some inspiration on this project from like things like Blender, right? So Blender has this like pretty sick, I would argue, node-based view. So if you create like a shader on this thing, you can like create a sequence of actions that colors this cube, right? So I could be like, give me like a sine wave for this thing, right? So I could be like, based off the, texture coordinate of this guy, let me like take the X position and feed this into a sine wave. One of these guys got to say sine, and then I can use that as the color for this, right? And I can maybe say, oh, that sine wave, the UV coordinates are not like increasing fast enough, so can we add like maybe like a multiplication node? Math, we like stick a multiplication node in between here. We stick a multiplying here, and then we can start seeing like, oh, here we go. Look at that. There we go, right? You can see that you have something like that. Now, I like the idea of this, right? It's kind of like a similar idea where we have like a sequence of actions that result in some output. But what I don't like is that when I work with these guys when I've worked with these guys in the real world, these can get really out of hand really fast, right? Because of the fact that you can like position these wherever you want, you have to kind of like work hard to make sure that like they're positioned in a way that's like sane. And so I kind of am thinking, if I like force a specific layout on these things and I make it so that like we're kind of like the connections are not something that we can define, but are like defined kind of by some other mechanism, then hopefully the like layout of this thing doesn't start to become like a major problem. I want to like experiment with this. I want to experiment with my own way before I decide, okay, maybe we need a node system, right? But that's kind of the plan. So I think we got to make some sort of like tree view. We got to make some place to like put the tree view. We got to find some dependencies and figure out how to render them. And then we want to like make sure that when we like click on the thing that we show the thing that we want to see, we want to look at. And then maybe at some point we're also going to look at like UI to adjust previous, to adjust like dependency or something. We'll see. But that's fine. Long intro, but there's a lot of context. Are you taking higher level architecture questions? I might. You can ask it, but I won't guarantee that I'll answer it. Unreal's has some shortcuts to keep things organized, but yeah, it requires the user to do it, yeah. Okay, so what I'm thinking, I could end up disagreeing with this later, but we have kind of like this object properties view that's kind of like always shown here. I don't really know how much I like this, to be honest, but for now, I feel like we could just kind of put the tree view on top here for now. So I'm kind of thinking that like in this view, we take like this stuff and we move it down a little bit. And then in here, we render like the tree, right? This is kind of what I'm thinking. And then like this guy is going to be too big to fit on one screen probably. So we'll probably like start with him zoomed out and then maybe let you like zoom in and pan around that guy and stuff. I was going to point out that you should suggest pre-thinking about what you want the UI to be like because it feels like a shaping the acts kind of thing from 10 meters saves you a lot of hours down the line. Yeah, okay, cool. Yeah, we'll see how well this plays out, but I think that this will work. And yeah, we'll see. We will see. So let's start there. we have some sidebar somewhere. And when we construct this sidebar, I assume that we could maybe find some space to put a thing in. So make sidebar, he creates a stack which has a rectangle, which is like the background, like this here, that's like the background rectangle. Then on top, he puts what? Sidebar stack here, object properties. So it comes from make object properties here. So I guess the object properties is what we had before. We could make some sort of like vertical layout thing. I wanted to suggest a tree system that really leans into the hard idea of photos, like in a timeline tree format. It's an image editor. The atomic unit of UI should be something like image, not something like a spreadsheet or a node graph. Yeah, I agree. Which is why I don't think I'm going to put anything in this tree about it except for the images. But I think that having the dependency graph is still important. So, but we'll see how I feel. We'll see. So, presumably here we're going to make some sort of layout here. This layout is going to hold the previous properties view. And then we are going to put the layout into the stack instead. And then if we want the tree to show up above these things, we just have to put that first. So let's just first allocate some space. So can we say that we're going to make like maybe some like I don't know if we have like a spacer or anything like that. I guess we'll just say that we'll make the tree now. So we'll say that we're going to have somewhere that's like we're probably like going to import some module. We're going to say like tree view is going to be like from tree view.zig, and then we can just construct this thing here. Tree view init probably will fail, and then probably we shove that here. Maybe something like this. Kind of immediate mode GUI. It is kind of like that, yes, to some extent. Not perfectly, but we have like long-lived widgets, but the widgets still do like re-layout and re-update every frame. It's just that there's interframe state that I wanted to capture, so I allow real widgets that live for long periods of time. Okay, so this guy needs a init function that returns a widget from the GUI framework. So this is going to be like this guy. And the widgets are like generic because the GUI framework doesn't perfectly like the GUI framework doesn't like know about the app, but the app knows about the GUI framework. So what we do is from the app we inject like actions that that the GUI can request of us. So that's kind of what this is. So we need to get our action here, and this is actually this. Cool, and then we'll just write this as unreachable for now. And this thing is always failable. This thing surely will take in an allocator for him to update with, but I guess we can cover that in a minute. UI action is not defined because I didn't define this correctly. Okay. Make check. Okay, so that compiles. So we're good. We've got a thing to play with. And so now, since this is unreachable, we're gonna have to like implement some sort of widget API. Derp days. Thanks for the prime. Much appreciated. So I guess, you know, our typical pattern here is that widgets implement basically this API. Widget implements these. So we have to create some vtable that is specific to this widget. And what are we going to do? Some of these things are optional, right? Like update, set input state, set focus. These are all optional. So for now, if we just want to kind of stub out some form of like section of the UI, all we really need to make sure is that we have like a get size that returns the appropriate size. The layout will say, hey, widget, how big are you, sir? And we will say, we are this size. And like most widgets try to adapt to their available size, we just won't. We'll just hard code it for now, just to see that this thing works. So we're gonna make a widget vtable, I guess. And this is gonna be like GUI widget associated with a UI action and vtable like this. And we're gonna have render and get size. So this is like dot render equals self dot render, but the self has to be capitalized. And then these have to be commas at the end. And it's actually not self because usually self is for generic types by convention. We're going to actually name this tree view is equal to self like this or this. Then we can use tree view here. Boom, boom. Okay. Then we implement the functions. You'll see why I said that and why I gave up on this in UTalks. Okay, we'll see. We will see. So our render function, he has some types that he needs. Pixel v box is from GUI. Pixel v box. Pixel size is from these. And we'll kind of stub this stuff out for now. He doesn't have to do anything. And then get size is the interesting one. So for now, he takes in a generic context, he returns pixel size, and here we just return something. Width 100 and height 100 for now. Okay, so now we just have to make the widget, which is just literally like return context is null pointer for now. We actually don't need anything for the context. And then our vtable is from widget vtable. And so hopefully what we should see now is that when we run this, first we're hoping to see it compile. I forgot that we have to actually specify that all of these guys are null. We have to intentionally mark these things as null, which I think is a good decision. But it means that we have to do this. This guy needs to say that he is a tree view. You'll 100% brute force your way through it, but you'll be mad the whole entire time. Hell yeah, dude. We will see. We will see. I don't feel like I've got like a fuzzy idea of what I want in my head, so I feel like it'll be fine. But we'll see. Okay, cool. So we do in fact see that there is some space allocated here for the tree view. The scroll bar for this part is still below, so it looks like we're chilling, and now we just need to make sure that we like make it like an appropriate size. So I think I've actually changed my mind here. I think it makes sense for this guy at least to fill himself width-wise. Maybe we'll return a fixed height. That seems reasonable. So we'll try to fill our width. So the way we fill our width is somebody's going to try to update us. They're going to say, hey, widget, yo, here, we got some new params for you, baby. And one of those parameters is the available size. So here we will stash that. So we'll stash the available width for ourselves. So we'll say, yo, we are a tree view. I know that you're giving us a generic type, but we know that that generic type will be ourselves. So we can just say like self width is available size width. We'll just fill it up. We will not try to fill the height. We will kind of fix that to be some sort of size, which means that here we need to stash width. And we will return that here, which means that we need to do the same context trick here. Valigo, hello, hello. What's up, you guys? We are working on adding a little bit of a DAG view for our image editor. So here's our UI mockup. We are adding this, where we're gonna add like a preview for like our image editor has like a sequence of images that turn into one bigger image, and we want to kind of visualize how we worked through that sequence. Because right now we can only see like a flat view. That's kind of annoying. So that's what we're working on. Valigo, thanks for the raid. Hope you guys had fun over there. I'm just gonna kind of try to stay focused a little bit. So apologies, but that is what we're working on. All right. So now this guy should be bigger, and he should fill the space. I think I forgot to say that the update function is part of this guy, so let's do that. Locked in. Yeah, it's a focus day today for sure. But thanks for the raid, much appreciated. Okay, so he crashed. Why? Because I assigned null pointer to our context like a fucking dumbass, like a dumb little dingus. So we actually need to allocate space for this guy to store some stuff. So he's gonna take in some sort of allocator. We're gonna specify that he's arena friendly, because we do use arenas around here, but sometimes we don't. So we want to specify which one is which, and we say let's make a return context. So this is going to be a arena create a tree view like this, and then we assign our default values like this, and then we pass them along like that. Boom. Unhappy. Why? Because when we call this guy, wherever we call him, he's like, yo, I need some stuff now. You got the stuff? Could you believe in this stuff? Sidebar. So it's here, we need to say, what does our allocator look like? We have an allocator for the lifetime of the sidebar. So that makes sense. So let's give him somewhere to live. And then no function name create, because I used a capital C. No capitals around these parts. No capitals allowed. Okay, cool. There's our playground. Maybe a little large, but that's good for now. We'll leave it. Okay, so step one is to find out like the direct dependencies of something. So I think that we can actually, if we launch this guy, first of all, we don't need to run a GDB. We don't. Let's not get crazy here. If we launch this guy with no input images, he automatically creates like an area that's kind of nice to draw in, like paint, right? So we have this here, and the stack here is that we have a drawing, you know, on one plane, and the drawing is drawn on top of something else. So we have like a shader that takes no inputs, and he's in charge of like the background, and then this guy's in charge of like the stuff we are drawing on top of the background, right? So we could start with this sequence. I think that would be the easiest, because it's like the sizes are guaranteed to be the same. There's only one dependency, and so we can kind of just start with like something simple and then work our way up. So what does that look like? We need to, I guess, extract the most, like which object is selected. I guess that's step one. We need to know what we are, which is going to be done on update. The kind of like expectation of the UI framework is that every frame we call update, then probably get size, then render, I think is kind of the expected flow. We can actually check. We have like a runner. He calls update, get size, handle input, then render. That's kind of his ordering. We don't have input to handle yet. We will eventually, but not right now. So in our update function, we are going to have to check which object is selected, which means that we're going to have a reference to our application. It's the only thing that makes sense. So I think it's like this, which means that on initialization, we have to pass that guy in, of course. And then obviously we have to pass that guy along to our storage. Okay. And on update, we're going to be like self app selected object. Maybe we like check the last selected object ID and compare if it's different. If we do, we regenerate the graph, but we probably want to walk the whole tree every frame. Maybe because like things might change between frames. We need some way of like tracking whether or not we need to regenerate our graph. So instead of doing that, right now let's just assume that we have to regenerate it every frame. Okay. So we are going to get some object then. And does he tell us like who he directly depends on? That'd be kind of hype if he did. So this object, he has update name, save leaky, load, dimensions, dependency iterator. dependencies is composable, and then as. So this dependency iterator is pretty close to what we want. Except this dependency iterator is designed to avoid like dependency loops. So he's not just going to give me like my direct ancestors, but he's going to give me my direct ancestors and all of their ancestors as well. So I guess we could go about this two ways. We could try to like adapt this existing thing to make it work in both cases, which is maybe a good idea. But for now, I'm just gonna make like a completely new thing. So I'm gonna put a fix me on here and say, surely there's some duplication with dependency IT. Dependency IT. But I'm not going to worry about that at this second. Okay. So parents is maybe the wrong word. Ancestors, like direct dependencies. Sure. And we could do this as an iterator. I wonder if it's easier or if I care less, if it's easier to do this as like an allocated array. Direct dependency iterator. This is fine. What are we making? We're making an image editor. Here, we'll show you, we'll give you a quick look at the mock-up. We are making this thing right here, a little tree view of how a sequence of modifications to an image results in whatever image we're looking at, right? So in this picture, you've got like a circle that's pasted on top of some guy's head and a Slurpee and a banister, and like these things are all parameterized in some way. We're trying to like visualize that tree of shit. Okay. So direct dependency iterator. This guy is going to hold something. It looks like here we did return object equals self. That seems reasonable. So he's going to be like, I have an object, and he is an object. And I'm probably going to have like my index into this guy, how many of these guys I've shown before. And I guess he is going to probably emit object IDs. I believe he's going to say every time you advance me, who's next? No, you know what? This actually does exactly what I want already. I'm a dumbass. This is already perfect. I thought when I was talking about like the fact that this thing was built to avoid loops, I didn't really think about this. But the way that this dependency loop resolution works is he recursively calls himself. So I'm just a dumbass. I just didn't read closely. And this dependency thing is already exactly what I want. So I'm just a dumbass. While iterator next, or dependencies, let's maybe just print out depends on this. And this will look at the dependency value. Okay. And then what we can do is we can just start clicking around and see how that affects the print statement. So we should see that when we are in the drawing view, we're seeing this depends on 0. And as soon as I jump off, he doesn't depend on anyone. So that's good. We have successfully identified our dependency. Okay. Now comes the actual hard part of trying to like render that somewhere. So let's think about our coordinate system. What are we going to fucking do? We are going to have, right, some image. This is going to be like us, right? And from there, we're going to draw a little line down and we're going to show like dependency, right? And we are going to have to recurse as well, to be honest, because eventually we're going to want to do this, but we're not going to worry about that right this second. We'll get there later. Okay. So I guess we have to have some coordinate frame, right? These guys are going to have like locations in some world space. So I guess probably just making this 0, 0 makes sense to me. And then everything will just kind of like go down in negative numbers um, by some amount. I guess that's one option. The other option is that we kind of are going to frame the whole world. And this can just live in like typical OpenGL space, -1, -1, 1, 1. I think I like that better. I think I like that better because then, like, in order to render this thing, all we have to do is like use our typical, like, take this OpenGL space and put it in that OpenGL space function, which we already have. So that's probably the play. Layout wise, what are we gonna do? I think we probably start at the top and we render, we like allocate some space for our thumbnail, I guess. Right? That makes sense to me, is that we need to know how big we are. And then we are going to have some way in order for us to say how far apart should these guys be. But let's just start by rendering us, and then we'll figure it out from there. So maybe we're gonna have some sort of like parameters to this guy. We're gonna have like inter like level distance or something. Maybe. I think that what might be easy here actually is if our boxes always have like a fixed size. Maybe they're always 1 by 1, and we'll like kind of put whatever images inside, we'll kind of scale them as they need, but every single box in here will be 1 by 1. I think that'll be easier to work with. And so I guess in order for us to figure out how these guys should be scaled into like our OpenGL space, we need to know how big the tree is, right? We probably find the height of the tree, and then we just scale the height of the tree to match this world. So I think that makes sense. So I guess what we have to do is we have to detect if everything has a fixed size, right? We have like thumbnail size. So we're gonna say these are gonna be, I don't know, we'll say that we'll make them 50 pixels wide. 50 pixels? No, we don't know the size until we've scaled. That was the whole point of this thing. So we want to do something like resolve thumbnail size. Maybe even the initial position. Let's do a find tree dimensions. Okay. That seems kind of reasonable. And even right now, we aren't worrying about like horizontal, so we'll kind of trigger that. We'll handle that as we need. So we'll just start with find tree depth. Find tree depth. Simple. Right? And this is going to take in object. So let's do this. We say app is svimp app. We have object is svimp object object. And we do this where we create our dependency iterator. We depth first search this guy, I guess. So we go find, I guess, like current depth is 0. And we return how many items deep it is. Yep. So for each object, we look up that object. We look up the dependency. Right. Yes. We're getting somewhere. Okay. So we take an app here as well, because we're going to need to look up maybe objects like this. So we look into the object storage each layer, and we pull out this object ID. And so we say object is objects get ID. We make our dependency iterator. We have the dependency, and then we just say return. I guess we're going to have like multiple children that we're going to look at, so we're going to try to find the maximum of each of those. So we're going to say ret is equal to the maximum of ret and find tree depth of objects with dependency ID and current depth plus 1. Okay, yeah. There we go, and then we return ret. Simple. Simple, simple, simple. So now here we go, var depth is find tree depth given app objects, self app, selected object ID, and 0. Okay. Depth is this. Let's start there. Debug. All right. So we should see 1 when we click on our drawing, and 2 or 0 when we click on the background. That is the expected behavior. So we see depth 1, click here, depth 0. It's working. Wow, crazy. Crazy. So we can use that now to figure out the height. So thinking again, we have to divide our OpenGL height into chunks of these guys. So we're going to have like inter layer spacing, right? So we'll say like level distance here, and we're going to describe this as a ratio, probably. So if we did like level height of 0.9 and the level distance of 1.0, then like this pair lines up to 1. That doesn't really make sense. Usually I work with these in pixels, which makes way more sense to me. So we have to divide the OpenGL height by the depth. This will give us, if we had no gap, how many things we could fit, right? That'll tell us kind of like this. But as soon as we want to add spacing between these things, what do? I think making the spacing be a ratio of the thumbnail height makes sense. So say this is like we want 10% of the thumbnail height as a gap between them. Now, what does that mean for this? We have depth. So first of all, this is +1. So this is going to be like num thumbnails, num thumbnail layers is depth +1, right? Because we saw 1 in the case we have 1 dependency, but if we have 1 dependency, there's 2 things to draw. Cool. I guess that means that the total height that we need, thumbnail height, is going to be like num thumbnail layers times like 1 plus level distance, I think. Yeah, like what's the formula for this? We have This is 2. And we want this gap, this. Let's draw 3 because that'll make it easier for me to reason about. So we know that the total height here is like 3 plus 0.1, 3 times like whatever height. We don't know the height yet, so this is going to be 3h plus 0.1 h times 2, because there's 2 gaps. Yes. And this equals 2, and then we solve for h. Yes. So if there were 3 thumb layers, 3h plus level dist times h times 2 equals OpenGL height, which means that we factor out the h and it becomes 3 plus level dist times 2 equals OpenGL height, and then we sub the numbers back in, so it's like num thumbnail layers plus level dist times open times depth equals OpenGL height. So now we can solve for h, and it's like h equals OpenGL height over num thumbnail layers plus level dist times depth. Okay, we got there. So num thumbnail layers, can we just make this everything F32 to make it a lot easier? Thumbnail height we have to find, and then level dist times depth. So we'll say level dist is already a thing, so depth F is float from int depth. Okay, cool. So this is now thumbnail height equals blah 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 divided by num thumbnail layers plus level dist times depth F. Okay, cool. Let's start by just logging this. Like this, I guess. And I guess what we expect to see here is that it's like 2 for if there is no children, right? So this 2, it fills up the whole fucking height. That makes sense, right? And then here we see that it's a little bit under 1, right? It took the whole space and it like cut out a little bit of room. So I think that makes sense for the gap. Okay, so now we need to like lay this stuff out. And we're assuming for now that laying out strictly according to height is fine. It might not be, but for now, we'll live. So we'll do some form of layout, and that layout basically has to map object IDs to where they sit on this in this little view, right? So okay. So let's just start with ourselves. We'll start with ourselves. We won't worry about anybody else yet. We'll just worry about our one thing. So we know that these object IDs are not going to be contiguous, but we do know that we're going to have like a fixed number of them. We're going to have to like, well, not a fixed number. We were going to have some number, some number of objects, as well as their like locations. So I guess that just means that we have like a layout. And this layout is going to store some stuff, I guess. So he's going to have like I guess data? And his element is going to be like object, like ID to bounds. And these are bounds in OpenGL space. So we can't reuse like GUI stuff for this. Yeah, that's fine though. That's fine. So this is going to be, we'll just use 4 floats. Left, up through 2. Right, top, bottom. We'll just do this. Is bounds right even? I wonder, we kind of know the size of these things is predetermined for all of them. So it's actually just center. So maybe we just do this. We just use a vec2 here. Seems reasonable to me. Okay, and then this is gonna have many of these guys, right? So I guess as we walk this, we not only want to find the initial depth, but probably how many elements we're going to be looking at, right? So saying find tree depth here is a little bit wrong. Can we pre-process? Can we move find tree depth into layout? And we'll call this pre-process. And this will return like pre-processed data. Pre-processed data, right? And in here we have, you know, the depth. Maybe even here we actually just call this the height. And then we also have num elements. Yeah, and so then we can just kind of move this stuff into here, which means that I'm kind of, we'll call this, let me think. If we want to keep the recursion in here, I guess we do keep depth in here. And then here, cur data is preprocessed data, and var ret is cur data. The ret dot depth is the maximum of these things. So next data is cur data. He's gonna like increase num elements. What do we do here? Depth is cur data plus 1. And num elements is cur data num elements. Am I stupid? Yeah, what were we doing before? We'll just do whatever we were doing before. So we have depth is cur data depth. Yep. Depth is the max of depth and what they found. Okay, so yeah, so child preprocess. Here we go. Here we go. We do this. His depth is cur data depth plus 1. And I think we actually feed in depth here. That's where I'm getting confused. This is, we still feed depth here. There we go. This makes way more sense this way. Okay. Then we get the depth is the maximum of the depth and their depth. and our num elements increases. Yes. So this is, it starts with 0, then num elms plus equals the preprocessed num elms, and then we return. There we go. And then I think we also increase by 1 here, right? So we have to do 1 plus because the child itself is wrong. So this is num descendants, I think. Right? So this guy's going to say like, okay, I have 0 descendants, and then for each of my children, I'm going to add 1. Say all of them have 0 as well. Yeah, okay. I think that makes sense. I think that makes sense. So can we start by doing, then when we initialize this guy, he is going to take in, I guess, the preprocessed. Which I guess can be an implementation detail. So he's going to take in the stuff used for preprocess. He is going to say preprocess this with objects ID and 0. Yes, this is starting to make sense. Then he just does all of that shit, and then he calculates the thumbnail height. Like this. The thumbnail height gets stored here, which makes sense. He looks at the depth. He does all this. Then he also needs to like allocate new data. So can we just have like our own allocator here that we reset with? Not if this is on init. Okay, so we start these guys as 0. These things start empty. That makes sense. Then this is no longer init. This is update. Yes. Okay. Then we do our preprocess. We update our shit. So we say self thumbnail height is these. Cool. Then we reset our data. So we have some allocator in here that is resettable. Okay. And we just say like, yo, get the fuck out of here. And then we'll say we have new data now. And it is we want to alloc some elms with however many things we counted. Plus 1. Yeah. And then we have to do something with that, which is going to be some sort of recursive function that calculates the bounds. Yeah. Yeah. So this is going to be like update, like layout elem. Okay. Layout limbs. Cool. Yeah, and he's going to do some sort of like recursive thing that's going to right now assume that like we always lay out in the center on X because we're too stupid to do anything else. Yeah. Yeah, okay. That makes sense. So we probably want like I think this is easier if this is a like acts like an array object, like an array list. So we're gonna make like an array. This guy is gonna be like bounded runtime bounded array of elem. That way we can just push into him without thinking. Which means that this guy has to be like runtime how does this guy get initialized? It's with an allocator and a capacity. So this is going to be whatever our capacity was, pre-processed data, num descendants plus 1. That's what we said, right? That is what we said. Which means here we'll just lay out the first one, I guess, for now. The first child. So his like Y position is going to be like current depth times thumbnail height plus the padding. So what was it? It was like the level distance. So it's like something like this. Yes. Okay. This guy's going to lay out his children one level below. And we're going to do something with that, but I don't know what yet. I guess we say like we have our data and we append something that's like the Y center. So for now, we're just going to say like what do we say it was? It's ID. It's ID. And center is 0 and X, Y center. We should be able to make that work for now. Cool. And then we lay out his first child only because everything's centered in the center right now. So doing more than one wouldn't work. Okay. So now we can update this thing with like, can update the layout, the objects, and the selected object ID. Yeah. And I guess we could just print the layout after. Like something like this. Let's see how that looks. Let's see how that looks. He's probably gonna be mad because layout here needs to have like his allocator passed in. So here he needs to actually create a sub allocator. So we have like our heap allocator and we're like, let's, you know, split off some like sub allocator of that thing. So we'll call this thumbnail layout. Okay, cool. And then this guy's gonna be mad because we need to pass in just the resettable thing. Missing field data. So this guy we need to set. Does he have a default initialization? He does not. We can kind of do this though. If we do this, then we can do this. What's this about? Yeah, this guy returns late, which is no longer true. Can this thing fail? He can, so he needs to be tried. All right, let's see where that goes. Num descendants here is a usize. Num elms is num descendants. Okay, and let's just see where this goes. Maybe? Okay, so we have an empty layout in both cases, which is not ideal. Not ideal at all. Did I call layout elms? I did not. That probably has something to do with it. I bet. Seems likely. Usize in F32, so as F32 float from int. Int from float, I mean. Yeah, no, float from int. Wait, what's the problem? What's it fucking pissed about then? Was it the next line? Oh, it was. Oopsies. This guy probably. No field name center. What do we call it? We called it location. Okay. This needs to be tried. True. Expected type void. Found this because he's like, I need to return an error. Sir, please let me return an error. Fine, if you're going to be like that. Error unit is ignored. True. Fine, we'll propagate errors. All right. So do we see a reasonable layout? So here we're seeing that one guy is rendered at 0, 0, which does not seem good. It seems like if we're trying to do the center of these things, then they should be offset by the center. So the initial value needs to be, we take the thumbnail height and the padding, but then we also add the thumbnail height over 2. That seems more reasonable. Okay, so given a thumbnail height of 0.95, we see the first guy at around 4.76 and the second guy at 1.52. And so hopefully if we add those numbers up, so if we do 952381 over 2, we get 4.7619, which means this is good. And then we say, what is 2 minus that, which is 1.523, which is good. So these guys are putting themselves in the right locations, which is great. This is all working as I expect. I guess the next thing to do would be to render something there. Let's give ourselves something to look at to kind of see visually how do we feel about it. You know, it'd be pretty cool. Add a screenshot feature that adds a screenshot directly to it. Yeah, I need to. We did an experiment on how, like a while ago, on doing copy paste of image into a Wayland client. And so it's on the plan. Like if I do this and I hit enter here, that just like goes into my clipboard. And so I should be able to like paste that into the image editor, but we're not there yet. But one day, we will implement that. Um. Okay. So to render. I guess for now, let's just draw a little box on where we would put each thumbnail, and then we can actually like put the thumbnail there later. How about that? How about that? So, that means that this guy needs some way to render stuff. Let's just give him like a little, like, square renderer. So, maybe like this. Squircle renderer. Okay, and this guy does what? I guess we have to stash him somewhere. So here. And then when we render, we're going to have to use this guy. I'm realizing I think the coordinate space is wrong. I think the coordinate space is wrong because I think I want the tree to be built out of widgets, not like things that I just render in OpenGL land, but like in reality, what's going to end up on each of these guys is like a clickable and probably draggable thing, right? Which means that like we need to support rendering like a widget, and widgets have like pixel positions, not like OpenGL positions. So this whole thing was wrong, but it's fixable. It is fixable. So wherever we were using OpenGL height before, this I think just needs to be changed into the height of the window in pixels. Like, yeah, widget height maybe. And then this just turns into widget height. And then everything else can kind of just stay in floating point units, and I think that's okay. This guy needs like bump widget state. This guy needs like the circle renderer. This guy's mad because now we need the, I guess we just hard code this 300. All right. Sure. Fuck it. We just make it a constant for now. That works for me. He's building. Okay. Looks like it worked. So let's kind of take a little peek skis to see how that feels. So now we're seeing that the thumbnail height is 142, which seems reasonable. That's just under half of 300. And then we get like something at 71.4 and 228. Those also seem reasonable given something that is 142 pixels tall. Yeah, I think that works. Okay. So now when we render, we're working in pixel units, which is great. So we need to call self in here. So we need this guy. We have our like renderer here, and we're gonna render some color. Let's just do like yellow, maybe. Just to get a feel. He needs a corner radius. We'll just use 0 pixels for that for now because it's just like for testing. Widget bounds is going to be the bounds of the thing we're rendering. So let's render a thumbnail height by thumbnail width thing. Oh, this also doesn't matter actually. This is irrelevant. irrelevant, and window bounds, I think. Or is it transform? He wants a transform? Yeah. So he wants to find a way to position our thumbnail width, thumbnail height thing in the window bounds at that position. So I guess we're going to make bounds. And this is going to be in pixel units. Which probably comes from layout. The layout probably has a way to say, like, get me the pixel bounds for the guy at this location. Yes. Okay. So how does he do that? He has the center. So he looks at like data items at index. We have like the location is here. So, and we have the height. So we're going to be like, thumbnail height over 2 subtracted from the Y location. And the left is the same. Yes. Okay, then we're going to return our thing, and his like top is top, left is left, right is left plus thumbnail height, cast to an integer, and bottom is the same. We're probably going to want to do like thumbnail height unsigned is like this. We should probably round here or something. But whatever. There we go, like this. Okay, so now we should be able to go iterate all of the bounds of the items in our list, in our tree. So we should be able to be like, for self layout data items. No. For 0 to the number of items it has. Fix me self layout items or something. Len, maybe. We get the bounds for the thing at I. And we try to render those bounds in the window. So we say, I think we have like utility, there's like widget to clip transform here. So we have like our pixel bounds in bounds, and then we have the window bounds, and it will automatically calculate the transform for us. Like this. I think this is the way we usually do it. We do need to specify that these guys have to be offset by the widget bounds. That makes sense. And let's just see how that goes. So everywhere we're using .y and x here, this is 1 and 0. Not bad. Not bad, dog. Expected 2, found 1. Oh, sure. Expected I32, found F32. So here we want to go in from float on both these guys. And these are I32s, I believe, because they could be off the screen, technically. And let's see if we get like some yellow boxes where we want to see them. No. No, we did not. So why the fuck not? Why the fuck not? Okay. So let's take a look at what's going on here. Bounds are these. Because it looked okay to me when I saw the initial answer. Oopsies. But clearly it's not. Left negative 71, right 71. So the width here of being 142 is reasonable. Top and bottom are like somehow backwards because I didn't write bottom here. This should be top here on that guy. So that kind of cleans up that. It does not explain why we are off the edge of the screen. Oh, it's because we wrote x0 instead of x halfway in. Aha! Okay, wait, hold on. So now we want to do something like our x here should be x center, which we don't have right now, but we can get easily. Maybe if we make this an F32, it makes our lives easier. So here we pass in a width like this, and we probably just say like x center is, you know, width over 2 or something. It doesn't really matter too much right now. And then we set this to 0 initially as well. Fuck. Because on update here, we now need to pass that guy in. So we pass in the width like this. He compiles. Let's run it. Let's run it and see. All right, that's not too bad. Okay, so I crash if I resize too small. It looks like there is a saturating sub that needs to be done somewhere. But I mean, overall, that looks like what I want. So if I go here, he fills the screen. If I go here, we get 2. That's pretty hype. Layout looks like it's working at least how I intended. Okay. Now what? I guess we want to actually render the content of the thing, right? We don't just want to put a yellow box there. We want to render the thumbnail. So what I think that means is that we probably want to make like a thumbnail cache on update. So for each object, we might have like duplicates in here, is something to think about. So maybe we have some sort of like texture cache, some map of object ID to rendered thumbnail. And we just render that in that slot. Seems reasonable. Now that means that like the layout allocator, this is kind of like per layout as well. So it almost makes me want to make like per frame data like this. And we're going to put the layout in here. And we're also going to put the like textures. Thumbnails? Oh, you know what? We might just put like full on thumbnail widgets in here. We have those already. What do those look like? Thumbnail.zig. Yeah. So these guys just take in a retriever. The retriever tells it the dimensions of this guy as well as its size. I think the thumbnail actually tries to fill the available area. So maybe here we just like we position like widgets. Yeah? But these should still need to be like a hash map lookup because the object ID could change. But I think duplicating them is fine. We will need to duplicate them actually to make like drag and drop work correctly. We're gonna have like multiple widgets, even for like the same underlying object. So doing this seems reasonable. Do the widgets live per frame? No. The widgets actually live long term because they support the textures being pulled out. Like they extract textures from like a spot, which means that really we just need like the texture cache here, which is the hash map of object ID to a texture. Maybe a little bit more, a retriever. Okay, so the way this is gonna work is like thumbnail points to some like gets like a structure that says like texture retriever. This guy has to retrieve the like latest and greatest rendered thumbnail. Are we working on an undo feature today? A different type of tree. We're working on this. We want to show like the tree of thumbnails that like create a composition in like the corner here. So the tree is not for undo. The tree is for like object dependency graph. Okay, so this guy's gonna hold some information. He's gonna have to hold texture data, I guess. And this thing has its like width, height, its size, I guess. Yes. And the texture. Yes, this guy lives in this hash map. And this is not how you do that in this language. It's these types of brackets. And I guess what we are going to do is we're going to like, maybe this is long-lived? Maybe. Let me think for a second. So every frame, the thumbnail is going to call like get texture. On this thing. As well as like get size. Right? We need render here. And he's going to, like, I was thinking like he would hold a reference to this hash map. But in reality, we probably just regenerate the thumbnails every frame because we don't know. Like the content of the thumbnail could change, right? We could go edit somewhere, something. So every frame we do want to regenerate them. So this guy could just be like, oh yeah, I guess this is right. This is right. So per frame, he is going to have a list of textures that bind to object IDs. Since object IDs could show up multiple times, we don't want to regenerate that texture multiple times if we don't have to, so we use a hash map. Cool. That makes sense. Which means that this guy, when he retrieves these, he's going to be holding a pointer to the texture cache. No. He's literally just like this. Yeah, why can't he just be like this? That seems reasonable. Then we just hand out these guys to our thumbnails as we create them. That sounds like it works. Okay, so these textures are going to be allocated from some allocator. So I think that we actually want like a GUI allocator here. Because this GUI allocator holds both like OpenGL allocations and heap allocations and can like reset them all at once. Which means that the layout here no longer holds this guy. Okay. Which means that this thing is probably gonna have like a reset on him, which kind of just like sets these guys to their default behavior. Yeah, something like that. He's gonna be like, reset the allocator and reset these guys to be empty. Yep. Yep. So we have per frame here. This guy then is going to have to take in a GUI allocator here. And we make our, you know, thumbnail, like tree view per frame or something, we call it. And then the other guys get automatically handled. Okay. This guy now needs to pass in the whole shebang. And not as a pointer anymore, because this guy holds pointers inside him. Yeah. Okay. Now we need to explicitly ask for the heap stuff here. Widgets is missing because... Are these per frame as well? I think yes for now. For now, we will make these per frame. These could be long-lived. I think. Should be even. But I don't really know how to do that easily. Because we don't know like which object IDs are going to be our dependents. We kind of have to hash the dependency tree and then check if that changed, and if so, regenerate the widgets probably. So for now we will do this, but we need to, like, they need to be long lived for like drag and drop to work and shit. But for now we'll just do it this way because it's easier. And this guy is by default empty, I guess. Okay. I forgot an ampersand here. Okay, and so now this is like per frame here. And here. Any other ones? Per frame here. And then we need to like try self per frame reset like this. Okay, now this thing is mad because this needs to be a slice. True. No alloc in here to reset. True. And I guess here we take in an allocator now. I guess. Which takes like self per frame heap arena. Oh, you know what you can do? We could get tricky. We know that this guy's stored in per frame. We could do one of these. No, I'm not going. No, we're not going to do that. We're not going to do that. You could do a little field parent pointer shenanigans, but it actually doesn't work right now because we don't have a named type to field parent pointer with. But we could. And I probably will later. But this is easier for now. Field parent pointer the allocator away. Okay. So I think that nothing should have changed yet. What's DAG? Directed acyclic graph. So basically, like, stuff depend on other stuff and I want to see it in picture. Basically, we're trying to draw this. A little picture, like a tree of thumbnails. Tree of thumbnails that represent the state transitions required to get from like one set of images to another set of images. Or I guess to one single output image. Okay. So now I guess we have got the layout. So now we probably want to populate our texture cache and create our widgets, I guess is what this is implying when I look at this. So here we're going to go like for each object in our layout data. We have like item ID, I think, in here. Yep. And I guess we're going to have like a renderer. So we have like there is like a frame renderer in here, I'm pretty sure. Make per frame renderer. Like where do I get one of these from? Make frame renderer, that's what I'm looking for. And this guy uses the per frame allocator. Uh-huh. And I guess we just render object to texture. So that means that our texture cache I guess we're gonna do get or put here using the per frame allocator. This guy uses the general allocator because he might do some, some freeze and shit. And I guess we use the ID here as the key. So if it's not in here, we need to make this thing the texture that we render. Is this thing failable? Yes. Okay. Yep. Cool. So that means that at the end of this, our texture cache should be populated. Expected type object. Oh. Fine. Fine, we'll transition the thing to a fucking object. You happy? Okay, and then what's he pissed off about? He's like, I expected a texture data, found texture. True. So this is gonna be like texture here. Then we're gonna be like width dims is we need to extract the dimensions from this guy. So dims is the object dimensions, and then he might have to go backwards to like reference other objects. We have to pass that in there, and then we can say that the value pointer for this guy is something that holds both of these guys, right? So it's like size is, I think we need to cast the dims. I think there are different units here than they want to be, so I think it's like this. So I think that these guys are in U sizes and these guys are in U31s, I think, if I remember correctly. Okay, so now our texture cache is populated. And we have a texture retriever that we can pass into some thumbnail. So if I remember correctly, we have to clamp the thumbnail. The thumbnail is going to try to fill, calling it a thumbnail is going to work wrong. The image that we put in our GUI framework is going to try to fill the available space. So we have to ensure that it has the right amount of space. But we can just do that by line. Yeah. So here we make a thumbnail and we just pass it the thing that we got here. So he has a few things that he wants. He wants an arena allocator, which for sure can be the per frame arena, right? Surely. What else does he want? He probably wants some like thumbnail shared state as well. So we need to stash that somewhere. So here we need like thumbnail shared is some, GUI thumbnail shared state, which means that it needs to be passed to us on init. which is easy enough for us to yoink out. I don't know, we'll see. Make check. Unused function parameters, so we actually have to say thumbnail shared is thumbnail shared. And eventually when we compile, we're going to get to the point where we have to pass that shit in. Unused local constant. True. So this guy has to be in our widgets. So I guess we allocate per frame widgets. Yes. So we're gonna make a bunch of these guys. Probably. And they are going to... How many of them are there? I guess however many things are in our per frame layout. Something like this. Now, I think we're in the same state here where if something goes wrong, like halfway through this, we want to make sure that these widgets are in a good state. So I think treating these guys as a bounded array makes sense. Right? Kind of like one of these guys. Which means that here, instead of doing this, we do like make these guys an array list and with GUI widget. And then we init this with our allocator. Okay. That's ugly as shit, but it probably gets the job done. Then on each frame, or on for each widget, we just push this guy. So this guy should return a widget here. Yes. And just like self per frame widgets append this guy. And I don't know, man. Something like that. So this guy's mad because we need to pass in the thumbnail state for him to work with. This guy's mad because this is now default initialized this way. Same with this guy. No ampersand on the default initialization anymore because it's a more complex type. This guy's mad because this guy needs UI action here because he's a widget associated with this specifically UI. Okay. What's going on here? Expected. Probably forgot try. I always forget try. You have to try. Okay, what's mad here? Expected type. Okay, let's read the error. Found error union blah blah blah. Right, so I guess we do have to write try here as well. True. What a windus guy. We need this get texture and get size to be marked as public. Otherwise, the thumbnail does not know how to call them. No field name width in texture. Because this guy's returning the wrong thing. He's supposed to return a pixel size. I'm just a dumbass. All right. That compiles. And I guess we do not expect anything to happen yet. Because we didn't actually try to render them yet. We're still seeing yellow boxes. But we should now be able to replace those yellow boxes fairly easily with our thing. So now we should just be able to like rip the layout and get the widget for this thing. And we should just be able to replace this with like widget render with the bounds and the window bounds. And I think that compiles. And I think that we should start seeing something reasonable in here. Oh, come the fuck on. Come the fuck on. So now I go into this guy and he, we bring him down. This is like kind of fucking annoying, to be honest. I don't like, there's definitely some things I don't like about this, but now we can see, like, at least we have like one element is now like in the simplest case, he is showing his parent in here, which is hype. Pretty fucking hype. That's pretty cool, man. Pretty cool. Cool. I think it would have been nice to cover some of this like UI stuff. I want it so that when I like click this guy, it like shows that in here, but we're not going to get there in the next 15 minutes. But what would be probably nice is to try to do some sort of like horizontal layout maybe. So like, is there an example of something that has two parents? Maybe if we were to create a new path from this guy, and we were to look at, okay, so this is kind of cool, right? We can see now this chain is starting to look kind of reasonable. It'd be nice to be able to zoom and stuff, right? But seeing like this mask comes from this path, comes from this drawing, comes from this background is pretty hype. Now here, this doesn't work quite as well because this mask thing, he's missing some dependencies in here. That's really interesting. Can we look at the dependency? Oh, it's because there's two? Ah, yes. It's because there are two dependencies to the mask multiplication. Right. So let's do that again. So we draw a little smiley face here. We crank it up so you can see it in the sidebar. And we create a new path from this guy. We cut him out. And then we click on this. So here we have drawing and mask. Mask is the second one. So if we were to swap these. Yeah, okay. Right. Okay, I see. So we need to make it now that we can visualize like the second part of the chain. So how do we do that? It means that when we do our layout, we need to somehow find like an X position that is reasonable here. So let's say 15, we're at 1 hour, 42 minutes and 17 seconds into stream, and we are finally on to the step 2 of our many step process. And we're gonna say X position. Right, let's try to have like multi-child elements. Why am I typing like this? Okay, so here, what do we want to do? It's like each element probably has like a width, right? So in the context of like, say we had something that had like, one child that has two children, right? Boom, boom. Now we've kind of said that each thumbnail has the same size, right? And here we might kind of have stuff like this, where like each of these guys is 2. And then maybe though, one guy is like only has one child all the way down, right? I think probably we need to like determine the width of the whole tree below us. And then probably we want to like space these guys out such that they have even gaps between them horizontally. So like in this scenario, even though this guy's like skinnier than these guys, we probably still want to lay him out with the same amount of space between them. That's kind of what my gut says. And so I guess on our pre-process step, we want to find like the maximum width of all of our children. So from this guy's perspective, he's going to look at my 3 children. Which one of you guys is fattest? And then each of these guys is going to look at their children to decide which one of them are fattest. I think that's the first step. So pre-processed data is going to have like width. Okay? And I don't really know what that's going to look like yet, but I think it's going to be kind of the same as depth, where we're going to have like width starts as probably the thumbnail width. this is not in pixels. This is like width in elements. So we're going to start with the width being 1, right? Unconditionally. And if we find a child that is bigger than that, then we have a problem. So I think it's the same thing where you have like width, just like depth, is just the maximum of myself and this child's width. No. No. Yes? No. We need to add it, right? Because like the width of this guy contains all of this space, right? So I guess my width, we're going to, oh, it's just num descendants. No, it's not. Num descendants and num children. Nope, width I think is more correct. So first we find like num children. Right, this is straightforward. So we have like our direct children like this, which is different than descendants, right? Then each, we have our width here. I guess we just say width is a u size equals 0. And we do this, we do what we were doing. We say width is the maximum of width and num and the output. And then at the end, we just do one last step to say that like width is the maximum of the number of children that we have in the width. Yes. Okay, that seems reasonable. Anyone see the recent Zig Showtime stock with the DVU outward? I watched some of it, kind of an immediate versus retained mode talk. I did not. But it sounds interesting. This seems like it probably does the right thing. So what do we expect here? We expect that we get a width of 2 for the top layer. Can we just like print out what we get here when we do the pre-process step? Width is pre-process data width. So we should see width of 1. Can we do something like create a composition here? And then our composition, let's just add. Every time we add something here, we see the width go up, which is good. So he's got like 5 things in here, right? And if I then create a new thing, a new composition that takes that composition in as like one of his children, my width is still 5, which is good. That means that this is tracking. I think, guys, I think we did something stupid. We did something stupid. Fuck, man, I hate that shit. Okay, so yeah, we did something dumb. I think what happened was something must have been like allocating and not freeing, and that just like completely fucked my entire desktop. That is the first thing that we have to fix here. That's a problem. Because that is fucking annoying. Alright. So it looked like the width tracking was correct. However, it looks like our memory allocation was not correct. So let's just get everything back where it belongs. This goes here. Boom, 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 boom. This goes over here. And then this stuff can close. All right. So let's be very careful here. We have some amount of time. I just don't know how much. So first of all, let's try to figure out if it's heap allocation or GPU texture allocation that's causing the problem. I don't even know. It felt like we should have done everything right. I feel like we were resetting the right allocator. But I guess not. Okay. So we're looking for this number and this number. Uh-huh. So actually, weirdly, seems okay. Maybe it was when we made a composition of composition. Right, so what did we do here? We made a composition that took 1, 2, 3, 4, 5 of these guys. We kind of like moved them around. So far, so good. And we made a composition that took this composition. And here we're starting to see VRAM maybe leak? No. Even that doesn't seem that bad. I'm a little concerned. I don't know where that came from. But things seem stable. So I don't know. I don't know. That's a little concerning. We'll keep an eye on it. But it does kind of line up with the idea that I didn't think we did anything like majorly wrong. There must be a bug somewhere else that I don't know. Don't know where it is. But anyways, let's go back to the mask case. So where were we? It was in like, I don't remember what we called this thing. It was in the like tree view probably. Yeah, here we go. Okay. So we determined that our width tracking of this thing was correct. And now we just need to make sure that the centering kind of works. So we have this, right? This is our thing. So in this case, we know that we are part of a row with 0 elements. I guess we kind of know like our width here is 1. And we are in some sort of like larger width of like 3 in this scenario, right? In this scenario, are we tracking correctly? This width is 4 now. I don't know if we tracked that right. Yeah, this is wrong. Our width, it's not just num children plus 1 here. I think it's literally we just add child preprocess.width. That seems more correct to me. Because now this guy's going to have a width of 2, 1, 1. We should be 4. That lines up. That lines up. So let's take a look at that. So we now know the total width. And I guess we probably want like, we want to render within the width of our subtree or something. Like we need to know that this guy has a width of 2, this guy's a width of 1, this guy's a width of 1. I think this is going to be like a little bit more complex than I originally hoped. So I think what we do is we just call it here. It's 4 o'clock. This is a good natural place to break. The stream crashed anyways. I think we just come back and we spend another day on this tomorrow and we try to do some like horizontal layout. I think we made good progress. Like part 1 of this thing where Oops. Part 1 of this thing where we render like the chain of actions. Here, you know, where we say, let's make a path out of this guy, and then we'll take the path and we'll cut out a thing, and in the thing we get the thing, and we get like the tree of stuff here. That's working pretty good. There's definitely more work to do. We need to make it so that we can like horizontally space these, but I think this is good progress for one day. So I think we call it there. Thanks for watching, guys. If you liked what you saw, we stream most days at around 12:30 Pacific time to 4 o'clock Pacific time. It is 4 o'clock Pacific time now. So if you're watching live, see us. You should see us between 3.5 hours ago to now. If you want to catch up, there's a YouTube link in the Twitch description where you can watch the 2 to 4 segment, which is like what you're seeing now. We have another segment called Happy Hour, which is kind of like less structured, more researchy. So the 12:32 segment today, we were looking at, we were investigating like, can we lobotomize an LLM and use it to play connections for us? We were just trying to like do like initial investigation in there, see if it's possible, trying to like figure out like what tools do we use to do that, where do the model weights come from, all that type of stuff. And then eventually one day that will become a mainstream where we actually do it. So if you want to see that stuff, you have to catch it live or consider supporting. One day this stream will end, right? I do not, this is not competitive with software development salary in the slightest. It's not even fucking close. It's not even competitive with like working at Starbucks. But the day where this stream ends kind of depends on how much money I have. And, you know, so if you consider, you know, supporting on Patreon, YouTube, Twitch, or GitHub sponsors, you know, each dollar kind of extends the lifetime of this game we're playing by some amount, right? So consider that if you want to keep this, if you want this stuff to keep going. Otherwise, no sweat. If you subscribe on Twitch, Patreon, or YouTube, you get access to the happy hour VODs in the appropriate places. I think that's it. YouTube, peace out, and Twitch, let's find someone to raid.